Time to play the game!
Hello. Now that we're done with preprocessors, let's move on to other keywords in C we haven't seen yet, such as Typedef. Typedef is a keyword that allows us to redefine a type, meaning you can create your own type. There are huge differences with the macro define, which allows you to do a replacement word by word, whereas Typedef really is for creating a new type. And I'm going to show you those differences between Typedef and define. How do we create a Typedef? Well, it's simple. Typedef plus the type of base we want to transform. For example, let's say I want my int to be called kashuit, which means peanut. As it's not a preprocessor word, it's really something that's executable. So we have to add a semicolon at the end. That's important. Now that I've done this, underneath my code I can write kashuit. The variable a, for example, and then a equals 10. And normally there shouldn't be any error during compilation. For the moment, you can't really see a difference with define, except that it's in reverse, meaning that kashuit was on the left and on the right was what's to be replaced. The real difference is during compilation. The preprocessor will take care of it, which requires other things, meaning Typedef also is a subject to the scope. What is meant by Typedef is subject to the scope? It means that, depending on where I put my Typedef, it will only affect that area. For example, here Typedef only affects the main. Let me show you. I'm going to create a new function as an example. Void ft_fct brackets void and declare a new variable kashuit, which I'm going to call a. And I'm going to do the same thing underneath, a equals 10. Normally, this should not compile. Here we go. There's a problem in ft_fct. I have kashuit undeclared because it has been declared beneath here. As I was saying, it's subjected to the scope. If I added the Typedef all the way at the top, out of the scope, it doesn't respect the standard, but that's okay. It compiles. That's the first big difference. The second difference is something we could not do with a define. Unfortunately, it doesn't respect the standard, but I'll show you just to be exhaustive. Imagine I write int space star and call it int underscore p. Now I have a new type of variable, int underscore p, which is an int star, an int pointer. Had I written this, you'll see, had I written int star a, b, c, the asterisk is in the wrong place. That's why we have to put it on the right. You'll see even better now. Here we can see that only a will be a pointer to int. B and C are ints. When we write this, here's what happens. Had I done hash define, let's call it intp in capitals, it'll be replaced by int star. So I had written intp, that's actually the same thing. The asterisk, instead of being on the left, it'll be on the right. Because it's a word-by-word replacement, so my a would be an int star, but my b and my c would be an int. However, with Typedef, if I wrote int underscore p, this time a, b, and c would be pointers to int. You probably don't see the point yet, but there are many points to this. The most blatant point is the last one I'll show you actually. Going back to writes man, which we've already seen with includes, etc., here you see that write takes a size underscore t and returns a s size underscore t. Those are typedefs, meaning that if one day the person who created write wants to modify its data type, by adding include unistd you have the typedef of size underscore t, and if tomorrow they want size underscore t to go from being an unsigned int to becoming a long unsigned int, they'd only need to change it in one place. And if you've used size underscore t in your code, they'll also become long unsigned ints. The advantage is that it really performs a thorough check during compilation, and it also tells us the names, and not int because it's not a word-by-word replacement. It's a typedef int kashuit. And behind it will confirm about your errors with a variable of type kashuit. It also allows you to find things more easily. That's it for Typedef.